Hello children, welcome to JACH math class. Here we are solving some problems on differential equation chapter 9 class 12 exercise 9.6. In this exercise 5 more questions we can expect fixed question. Here I am taking some questions which are from question paper. Observe the problem. Cos square x dy by dx plus y equal to tan x. Here this is not in the standard form of linear differential equation, because to get that in the standard form dy by dx coefficient should be unity. Here cos square x is there. So to get that into the standard form, divide the entire equation by cos square x. You will get dy by dx plus 1 by cos square x into y equal to 1 by cos square x into tan x. We divide the entire by cos square x. Now dy by dx plus 1 by cos square x can be written as secant square x into y equal to secant square x into tan x. Now this is of the form dy by dx plus py equal to q. Our p is equal to secant square x and q is equal to secant square x into tan x. Now we can find the integrating factor. It is equal to e power integration of p into dx. So e power integration of p is secant square x into dx. So it is e power secant square integration is tan x. Now our integrating factor is e power tan x. Now let me find the general solution to this equation. It is y into integrating factor. It is equal to integration of q into integrating factor into dx plus constant of integration c. Y into e power tan x. It is equal to integration of q is what? It is secant square x tan x into integrating factor is e power tan x into dx plus c. We have to integrate the RHS part. For our convenient, consider tan x equal to t. If tan x is equal to t, then secant square x dx it is equal to dt. Substitute for the above, you will get tan x is t e power t and secant square x dx is dt plus c. Now it is in product of two function. We have to integrate by using parts. So first function, let me consider it as t. T into integration of e power t minus integration of differentiation of t is 1, integration of t is e power t plus constant of integration c. Integration by parts, if you want to write your formula uv dx, it is u integration of v dx minus integration of d by dx of u into integration of v dx whole into dx. That we applied here directly. So you will get t e power t minus e power integration is e power t plus c. So replace your value e power t is what actually tan x. It is the common term. So tan x minus 1 plus constant of integration c. This is y e power tan x. If you want simplify this e power tan x, if you cross multiply it get cancelled. You will get tan x minus 1 plus c by e power tan x you will get. So if you take to numerator, it is c into e power minus tan x, which is the required general solution to the given differential equation. Hence the problem. We have one more problem. I think maximum problem we solved. Let me solve one more of the same type. This is also one of the question from the question paper actually I picked. Let me solve this. Observe this. To solve this one, you cross multiply. What will you get? Y dx by dy plus x minus y e power y equal to 0 it is. So you have to divide the entire by y to get in the standard form. You will get dx by dy plus x by y minus y e power y divided by y equal to 0. So dx by dy plus x by y equal to, shift that y will go, you will get e power y. Now this is of the form dx by dy plus px equal to q, where your p is equal to 1 by y and q is e power y. So integrating factor is e power integration of, it is in terms of y, so it should be with respect to y. So e power 1 by y integration is log y, it will get cancelled, you will get y be the integrating factor. So integrating factor is y. We need to find the general solution. General solution to this is x, because dx by dy, so x into integrating factor, it is equal to integration of q into integrating factor into dy plus constant of integration c. X into y equal to, what is our q? Our q is e power y. So e power y into integrating factor is y into dy plus c. As usual, what we solved before, first function is y, integration of e power y is e power y minus integration of differentiation of y is 1, e power y integration is e power y into dy plus c. Now let we solve y e power y minus e power y integration is e power y plus constant of integration c. Take e power y common factor, y minus 1 plus c. This is our xy. So here we solved in terms of dx by dy. So general solution x in terms of y. If you want, you cross multiply e power y minus 1 divided by y plus c by y. If you take that to numerator, c into y power minus 1, which is the required general solution to the given differential equation. These are all the problems of linear differential equation. From these you can expect 1 5-mark question. All problems I considered are all the question paper problems. Go through it. Thank you.